Okay, guys, listen up. So, have we got everybody? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10. We're Miss Juliana. She wasn't in today. No. Is that the only person we're missing? Yeah, okay. Right, so what we're going to have a look at is practical Turkey. Come on, we're starting. So what we're having a look at here, practical problems using exponential and log. So just like with the sequence and series, there's not any new formulas here. We're just using what we have so far, but applying it to sort of word-based problems. So I'll give you a couple of examples which we can do together. The first one, for example, has Colin talked to you about any of the biology experiments you'll do?
Yeah.
No? Yeah? Which one has he talked? Just the essay? Okay, all right. See, there's a couple of things in biology and physics which has an exponential shape to it. I'll give you an example. So, we'll take something like cup of coffee or some sample of hot water, it doesn't matter, and the temperature theta equals, we'll say 30 plus k e power minus 0.2 t. So here I'm giving you the temperature, this is in Celsius, as a function of time, which we'll say is in minutes. But I don't give you all the information. You're missing the k here, for example. So my first question might be to find the k. So to find that, I need to give you some more information. So maybe I'll say something like initial temperature is 50 degrees. So at the beginning the temperature is 50 and then the temperature will change after this time. So now we have enough information to find k. So in this formula what you do is you replace the theta with 50 and you get 50 equals 30 plus k e minus 0.2, and what's the t here? It's 0. So e power 0 is 1, so we end up with k equals 20. So if I just scroll down a little bit, we get this theta equals 30 plus, what did I say k was? 20 e minus 0.2 t. Now part B, we'll want to make a graph of this. So, which type of graph is this? Well, this is the one when A is positive and B is negative. So, is that increasing or decreasing? Decrease. And where do we start here on the y-axis? Where? No. 50. Remember, I said in the question initially is 50. So when the t is 0, we get 50. And then the graph decreases. So the graph goes down like this. So then my next question, and this is one I'll let you try first before I do it. Now that we have our formula and we have a graph, maybe I would like to know when will the temperature be 25. So I want to know at what time or when or how long until the temperature drops to 25 Celsius. Do you understand? So what I want you to try is, when will the temperature theta drop to 25 Celsius. Okay, so this is one I'll just give you a minute to try. I want to know the time for this temperature. And the key is this equation is what you need to use. So see what you can do. Not too hard, please. You might break something. Yes? You have an answer yet? Yeah. Okay, let's have a look at this now. So, I'm looking for when the temperature is 25, yeah? I need to make the theta 25. So basically my question was to solve this equation. So what to do first? Well, I'll bring the 30 over to the left. 25 minus 30 is minus 5. And this equals 20e minus 0.2t. And then you divide, and the answer is 5 over 20, which is 0.25 equals e minus 0.2t. And this is where, you get to the answer. Because if you try to solve this, you put a log here, yeah? And you put a log here, and these cancel, so you can get the t, but here's the problem. You can't get the log of this number. So what would be the conclusion about this temperature then? Yeah? Not undefined. Yeah, so there is no time that will make it reach this temperature. So if you think about this maybe as a biology experiment or a chemistry experiment or some experiment, you have a cup of coffee or a cup of tea and its temperature at the beginning is 50 Celsius and you leave it in the room to cool and it never reaches 25 Celsius. So what does that tell you about the environment then? Yeah, so it means that the temperature in the room must be more than 25 because the cup never reaches 25. It never cools down to this temperature. Yeah. So I'll give you another one to do, but we'll make it a little bit easier this time so that does have a, let's see, what did we go with last time? 25, wasn't it? Yeah, so let's say this time, when will the theta equal 30? Let's say 35 Celsius. Okay. Yep.
Minus 5 over 20. Minus 4?
Nope. Minus 0.25.
Really?
Oh, really? Yeah, trust me. I thought so.
Thank you.
Because last question we can't write anything.
Oh yeah, so what you would say here, this one is no answer. The previous one, there isn't a time.
There isn't a time.
There isn't a time for when it will reach this temperature.
So the exam will say no answer.
I don't think they'll make it as difficult as this in the exam. They'll just give you one where there is an answer. I mean, they might, but the answer would be no time is possible. Yeah, you could just say no answer. Okay, do you have a time here? Yeah. So we have 35 equals 30 plus 20 e minus 0.2t. And then next we have 5 equals 20e minus 0.2t. So we get 0.25 equals e minus 0.2t because I divide by 20. And now to cancel the e I use log. Log here and log here. So they cancel. And now I'm left with, on the right, minus 0.2t, and on the left, log of 0.25. So to finish, I get t equals log 0.25 over minus 0.2. What's that? 6.9. So about 7 minutes until it reaches this temperature. Oh, I said at the very, very start that the unit is minutes for the time. Yeah. Okay, do you have this? Yeah, you have this? Yeah, okay. So, let's see, do I have my graphing program open? No, not yet. Okay. Let's do another example that's like this, but a little bit harder and a little bit more like what you get in the exam. Can I scroll down? I'll return to this in a moment. So, we'll say, let's pick a interesting one. Come on. Exponential model. So here, when a question or something describes a process as exponential or an exponential model, this is just a way of saying the thing you're looking at will have this form: y equals ae bx. And if I said a linear model, then that means the thing you're looking at will be y equals mx plus c. So to give you some examples in science, just so you can have a context, most things that grow in biology would be exponential. So when you're looking at bacteria or cells or anything like this, the growth would be exponential, but only for a certain part of the process, okay? So once you write these two words down, I'll just scroll down. Do you have this? Exponential and linear? Yeah? Okay. Can I scroll down? Yeah. So, just to give you a biology example, I don't know if you've done this, if this is semester 1 or semester 2, but if we look at, say, something like fetus development or something like this, and here we have size, which maybe could be in milligrams or grams, and then here is time, which maybe could be in days. The growth at the beginning is very, very fast. So it starts off with 1 cell, divides to 2, divides to 4, divides to 8, divides to 16. But of course this doesn't continue forever, because when the baby is born, it doesn't continue to grow twice as big every day, because that would make a big baby pretty quick. So it's only exponential at the start. I'm not doing it exactly honestly to the graph. I'm just giving you the idea. So it'll be exponential at the start, but then after some time it will then become a linear graph. So for example, this could be the first trimester, this could be the second trimester, and it might continue for linear like that. But then after you reach much past this and say 20 years, then the graph is then flat. There isn't much growing after that then, yeah? So what I'm trying to say is that in biology, a lot of processes, especially in their early stages, is exponential in growth. It will reach a linear, and then eventually it'll flatten out, and if things go badly for it, then it will start going back down then, okay? So we'll look at sort of a biology example. Yeah?
Enzyme.
If you've seen a graph like this with enzyme activity or something, is it?
Saturation.
Saturation, yeah. And what's on the x-axis in your enzyme? The temperature, is it? Oh yeah, that's right. So as the temperature increases, the activity increases, but only up until a point, and then it decreases then. Yeah, so the graph will probably look something like this, and then does it flatten out and come back down? Yeah. So on the x-axis is temperature. What letter do you use for column? T? Yeah. And we'll put that in Celsius. And then on the y-axis, that's activity or rate of reaction, is it?
Yeah.
So I'll just say rate of reaction here. Okay. So as our second example, we'll use this one from biology. And this is usually like 20, 25, 30. Is this kind of the numbers you'll have to? 40 is the optimum, is it? Right. So we will only look at the graph up until 40, and then maybe here will be 20. It goes back down, yeah. It's too advanced for us. We'll just look at the graph from up to here, okay? So from here to here, it's roughly exponential. And I need to give you two numbers on the y-axis. So here, I don't know what units you use for reaction rate, but we'll just call them units. Okay, so we'll say here is 2 units, and let's say here is 3 units. Okay. So what we want to do, we know this is an exponential model, so we know that I'll call this OR for reaction rate rather than just OR. We know that OR will equal A, E, B, T. When we say something is exponential, we mean the relationship between the OR and the T, the X and the Y, will be of this form. So what we're going to do is use the 2 points that we have to find the A and the B here. Okay, so this is a very common, listen, this is a very, very common exam question. The story will change every time, but the idea is the same. They are giving you 2 points which are exponential in their relationship, and you have to find the A and the B. So like last year, it was hotel prices. The year before that, it was bacteria growth. You know, it doesn't matter what the story is. The format is the same. So what we do is we look at this one here, 20 Celsius. When the temperature is 20, the reaction is 2. And then we look at this point here. When the temperature is 40, the reaction is 3. So what I want you to try and do for me is I want you to try and solve these to find the A and the B. Okay, so try and solve this to find the A and the B. And I'll give you a little hint. There's 2 ways to do it. One of them we haven't done, but some people might have seen it. But the other way we could solve it, which we have seen, is substitution. So you could use the substitution method here. You could find A in both. So see what you can do. Okay. So let's have a look at this. Now I said there's two ways to do this one. One way you could do it is you could say A equals 2 over E20B, and here A equals 3 over E40B, and then make them equal. But there is another way to do it which I prefer. It's a little bit quicker, a little bit neater. Not substitution, dividing them. Yep. So what you do, and this is important to note, I might have said this in the tutorial. Yeah. When you have two equations, you are free to add them, subtract them, as you know, but you can also multiply or divide them together. So here we divide the two equations. We put one over the other. What's nice about this method is it makes the A's cancel. And this will be E40B minus 20B, 20B. And here it is 1.5, yeah. Then we simply have to put a log on both sides. And now we have 20b equals log 1.5. So now I divide by 20 and I have my b. Can someone tell me this, please? 0.025. Give me one more. 0.0. Oh, sorry, 0.00? 25. So 203. Yeah. Is that what you got? Yeah. Now, we still have to get the A. So what I'll do is I'll put this one in here. And I have A equals 2 over E20B, which is 0.0203. And what's that, please, if somebody can type that in? Lots of 8s, is it? 8 point... No? What's this here in total? Oh, okay. Like this, yeah? Is it? I don't trust any of you now.
No, about
Hang on. Quiet, please. 1.92 if I type this in exactly. Yeah.
Exactly.
Yeah, exactly.
Hang on, be quiet. Right. And let me just check the other one. Yeah, this one here. So this is right. Now, the A. Okay. Oh, sorry. Long day. Right, 1.33. Okay. So now we have our A and our B here. So what this means is we have the formula that relates the activity with the temperature. Yep, we have the reaction or the activity or whatever equals A, E, B, and temperature T. So if you know the temperature, we know that the reaction, the activity. So for example, just as a really quick question, tell me what the reaction should be when the temperature equals, what do we have, 20 and 40? Yeah, so tell me what it should be when it's 30, the reaction rate. If the temperature is 30. Let's have a look. Now wait. Yeah, listen. Yeah, it is. Listen. When the temperature was 20, what was the reaction? Oh, I think I said it was 2 units. And when it was 30, it was 3 units. So because our temperature is in the middle of these two, our answer should also be in the middle of 2 and 3 units. So I got 2.45 when I put the temperature of 30 into this formula. I got answer is 2.45 units. Okay, so what I want you to do now, can I scroll down a little bit? Yeah.
Just one question.
Yeah.
How did you know where to put the temperature and the R? I mean, in the exam they give us the equation itself.
They usually do, yeah.
So they'll give us like.
They'll give you, in other words, in the exam, they'll write this down. Yeah.
They'll write this down. So we'll know how to do it.
Yeah. Okay. So, if we go back here to our graph, it looks exponential like this. From, what did we have here? 20 and 40, wasn't it? This is in Celsius, and this is in units. This is R, and this is T. Now, what they sometimes like you to do in the exam is, instead of using an exponential, in the second part of the question, they might say, okay, instead of using an exponential model, EBX, use a linear model. So our 2 points, 20 and 40, they want you to use a linear model. So in other words, they want you to find the equation of this one. Now this, of course, will be wrong because the shape of the graph is a curve. But what they like to do is they like to ask you to compare your answer that you get with the linear with the answer you get with the exponential, and they want to know how much of an error was there. Sometimes the linear is nearly as good as the exponential, and this is the point that they're making, that for some graphs the exponential and the linear is not too different. It's much easier to calculate the linear. This is the point that they're making. So what I want you to do now for a minute as kind of basic revision is to get the equation of this red line. And just remember, what did I say? This was 2 units, and this one here was 3 units. So give me the equation of this line. It should only take you 1 minute to do. You remember how to do this? I think it was literally our first lesson. It's a long time ago, huh? Yeah. I think it's longer than that, actually. Yeah.
How come?
Yeah. It was our first lesson in CAV 009.
Yeah.
Oh, the
Yeah.
good old days.
Yeah.
Where you warned us.
I did.
Wait a minute.
Nope, nobody does. Right. You weren't there. Okay. It shouldn't take you too long to do. So we have or equals mt plus c, which is just like y equals mx plus c, because this is the x and this is the y. To find the m, I need 2 points. This point is the point 20 and 2, and this one is 40 and 3, this one. So the m will be 40 minus 20 over 3 minus 2, which is 20. So you have or equals 20t plus c. And again, to find the c, use a point. 20 minus 40 over 2 minus 3. Oh, sorry, did I write upside down? Yeah, so it's 1 over 20. Oh, that makes it ugly here. No, it's quite different, yeah. I have this upside down, I'm sorry. I should have had 3, I'll write it again here. I should have had 3 minus 2. No, it's y2 minus y1 over x2 minus x1. So this is 1 over 20. I get or equals 1 over 20t plus c. Now, I'll use this point for my c. So I have 2 equals 1 over 20 times 20 plus C. 2 equals 1 plus C, so C equals 1. So I get, or, guys, chill, be cool, would you? Acting like that, I have to be honest, we look like a total dork, so just, well, we don't have to let other people know that, so just tone it down a bit, okay? Or equals 1 over 20t plus 1. Now what I'll do is, we'll calculate the or when the t is 30, and see what answer we get. So here I get or equals 1 over 20 times 30 plus 1. What's that? 1.5 plus 1, which equals 2.5. What was the answer I got when I used the exponential model? 2.45. So the difference between the two models, it's small. It's not much. It's only a small difference of 0.05. So the point that they're making here, they would then finish the question by saying, compare the two results. So you would just say for one sentence, the difference between the two models is quite small, you know. Or you could say, although the exponential is easier, the exponential is more accurate, the linear is easier to use, and the difference is the error is only small. It's quite small, okay. So sometimes they like you to compare the two, and the result is a bit surprising. It's more accurate than maybe you would have guessed at the start, okay? Is it even less than? I think the other answer was 2.45, wasn't it? Yeah, so 0.05 then is what I wrote. Yeah, so it's quite small, Okay, next. Hey, focus. So next we'll do a chemistry example then. Okay. Please listen carefully because I'll be using some basic chemistry terms which maybe you've done already, maybe not. But even if you haven't done it already, you should be able to easily understand them. So just a simple yes or no. With Lorraine, have you done pH level?
Yes.
Great, okay. My question was, with Lorraine. Right. Okay. That's fine, be quiet now. So, you haven't done it with Lorraine, but you've done it with Column. And with Column, guys, please, with Column, did he give you a definition of pH?
Just the first step is this.
He mentioned it.
Guys, listen, just one at a time, okay? Be quiet. For example, you. Have you done pH with Column? Yes. You remember doing it with him. And did he give you a definition or did he just mention it? He just mentioned, okay. So some of you would have done pH in high school maybe. But with Column, when he mentioned it, he would have said it measures if it's an acid or a base. Yeah. So in chemistry, you will do pH as well, and the definition I'm going to give you would be the definition that you'd get in chemistry, okay? And it's not a major definition, it's quite a straightforward definition as a formula. So as a formula in chemistry, pH level of a substance is defined as minus log base 10, the concentration of H plus 10. And you would have done concentration, of course, in chemistry. What's the unit for concentration? Moles per liter. Yeah, moles per liter. Yeah. So this is the definition. Listen. This is the definition that I'll use for pH level. Listen. Minus log base 10, concentration level of H plus, H positive. Ions then, yep. So, we'll do an example here. We'll say something like part A. The concentration of, for HCl, you've done HCl in chemistry? Yeah. We'll say the concentration of H plus equals 0.1. So what I want to do first is a simple question is calculate the pH level if the concentration is 0.1 and what's the unit? Moles? Moles per liter, isn't it? Moles per liter. Okay, so this is an example where a very, not a common example, but this is one where you need to use base 10 on the calculator. Let's calculate it. pH equals minus log base 10 of 0.1. The answer is 1. So the pH level is 1 here. So does that make it an acid or a base? Strong or weak? Strong acid, very strong, because it's very low. Neutral is 7 and base is up to 14 then, isn't it? Yeah, above 7 then. Okay, so part B. I tell you then, let's see, let's say something like the pH level. I don't know, some other material, something else. Say pH level of H2SO4. Let's say the pH of that is, well, would it be big or small?
Small.
It'd be small because it's quite a strong acid. So I'm going to give you the pH level, and then I want you this time to tell me the concentration. So you're working backwards here. You have the pH level, and now I want the concentration. So here we have 0.06 equals minus log base 10, the concentration of the H plus. So what should I do first here? I'm going to bring the minus over to the left, and then I just need to remember the basic definition of log, which says 10 to the power of minus 0.06 equals the concentration, and what do we get here? Yeah, let me just type in 10 to the power of minus 0.06. We'll get the concentration is 0.87 divided by, oh sorry, because the H2 there, isn't it? Yeah. So this is, so should I really have a H2 here, should I? Yes, it's 2. I should have divided by 2 earlier, shouldn't I? I didn't really want to make this a complicated chemistry equation. Yeah. But no, I know what you're saying. I should have had a 2 in there. Yeah. Because this. But this is not chemistry, so we'll just ignore that.
No, but okay.
Not my problem.
Yeah, it's my problem.
It's your problem. Yeah. Okay. C. So we'll go on to a different material. So we'll say the pH level of apple juice is 3.5. And this time we'll say we have 200 milliliters of apple juice. So my question is, how many positive hydrogen ions are there? So we'll do this one together. My question is, I want to know how many positive hydrogen ions. Not the concentration, how many? Okay, so let's look at this one together. Using our formula, pH 3.5 equals minus log base 10 concentration of H plus. Here I'll get minus 3.5 equals log base 10 H plus. So the concentration of H plus is 10 to the power of minus 3.5 So here, it's quite a small number, isn't it? Yeah, it would be 0.000316 then. So that's quite small. That's moles per litre. Now, how many litres do I have? How many litres do I have? 0.2 litres is how much I have. So if I want to know how many moles of H2 I have, I would take 0.000316 multiplied by 0.2. And what do we get here? If I multiply this by 0.2, of course I get a smaller number. 0.012345 moles. And this is moles of what? Our positive hydrogen ion. But still, that's not what I wanted. My question was, how many times Avogadro's number at the end to finish this? So I take my 0.12345, and Avogadro's number is 6.06. 6.023. Like this?
Yeah.
2.2, is it? Not minus, yeah. I'm just going to say 6. 10 to the 23. Yeah. If I want to make Avogadro's number 6 times 10 to the 23, that's what I'm going to do for maths class. Because I don't need to be super accurate here, because I'm going to round it off at the end anyways. So if I take my last answer and multiply it by Avogadro-ish, I'll get 3.8 times 10 to the 19. So if I round it to one significant figure, I'll get 4 times 10 to the 19 ions of H plus then. So that's how many positive hydrogen ions are in the 200 milliliters of apple juice. Question? Okay. This is okay? Yeah?
So what was the question again?
The question was, how many positive hydrogen ions are in apple juice? Wait, before you go. There are...
I didn't move.
Don't move.
Okay.
Because you're just wasting time. I just want to tell you about the homework, which questions to do, okay? So what I did there was roughly... Just stop moving and just listen. Just stop moving. No. Just listen, then write. Listen, understand, then write. Okay. So, what you have for homework, there are 10 questions. However, the one I did was very much like number 9, so I don't need you to do number 9. So, of the 10 questions, they're all practical. Try them all except for number 9 then, okay? So, you do 1 to 8, and then number 10. Some of these questions are exactly like exam questions, so you do need to practice them. And just so you know which ones are exactly like exam questions, the first few questions, basically 1, 2, and 3, they're pretty much exactly like exam questions. So you can't find them difficult. You need to do these to make sure you know how to do them, okay? And you need to try them all. Do all except number...
Okay, I understood.
Do all except number...
9. But,
now, go away. I'm tired of looking at you. What?
Question.
Yes? This one?
Yeah.
You're coming mad.
Man.
Oh, but no, you might do a question like this with Lorraine. In fact, maybe a little bit harder. Yeah. Okay, let me stop this.